So here are the things that IB wants you to know in terms of vectors and scalars, you guys. This is topic 1.3 in the syllabus, and so the essential idea, some quantities have direction and magnitude, others magnitude only. This is key in correctly manipulating those things. So vectors and scalars, I think we've talked conceptually about what they are. We talked a little bit about vectors on Monday, but today we need to work a little bit more maybe on how you combine and how you resolve vectors and solving vector problems. So when vectors are acting in the same plane, in the same direction or the same plane, super easy. It's just algebra, right? You add or subtract. And that's where the positive and negative comes in. We've been talking about with gravity, the acceleration of gravity can be either positive or negative, and velocity can either be positive or negative depending on the direction. That's really helpful when you just are adding them or subtracting them when they're all in the same plane. And this is all review, you guys. Again, you know, when you're dealing with vectors, to try to find the magnitude of adding two vectors, you just, if they're perpendicular, it's easy to use the Pythagorean theorem. When we're finding the angle at which the resultant goes, we'll use trigonometry, sine, cosine, or tangent, depending on what you know. So far, so good? If you're listening at home, go ahead and give this a try. Hit pause, sketch what you think the resultant of these three vectors are. All right, there you go. Oh, gosh. There you go, people at home. You guys want to say hi? You can say hi. Hello. All right. And again, just reviewing the way we add vectors. Remember, you place the tail of the second one at the tip of the first one. Your resultant goes from where you start to where you end. All right, so for example, you draw your first vector, you place the tail of the first one at the tip of the, or the tail of the second one at the tip of the first one, and your resultant goes from where you started to where you ended, not the opposite direction. There's also a parallelogram method. Feel free to use that one if you prefer. Basically, you take your two vectors, you make a parallelogram, your resultant is the diagonal. And then there's the wrong method, right, which we don't like. Don't do that one. The most common mistake I see when people are adding vectors is they draw one, they draw another one, and then their third one they go back to where they started from. And so this will have the correct magnitude but the wrong direction by 180 degrees. That's all. Okay. Reviewing right angle trig, SOHCAHTOA, Pythagoras comes in, but all of this stuff comes in quite a bit with vectors. Okay. So the thing that we really need to start getting a grasp on is how we do arithmetic, what we do with things, with vectors, when we add or multiply or divide. We've already talked about adding vectors, that's fine. When you take a vector and you multiply it by something that is a scalar, just by a number, that's pretty easy too. It just changes the magnitude or the length of the vector. It doesn't do anything to the direction, okay? Unless, of course, it's a negative number. So let's look at an example. So here's an example. There's a vector, a velocity vector of 4 meters per second, and let's say, oh, times 3. That's pretty easy, right? The direction doesn't change. I have to make it a lot longer. It just becomes 12 meters per second. No problem. All right? If my scalar happens to be a negative number, then the direction just changes by 180 degrees. Easy peasy, right? Okay? This is a skill that you need to have, and the IB asks you to do this quite a bit. So when we added vectors, we just placed the second one, tail to tip method, drew our resultant. Subtraction is a little bit different. When you subtract vectors, okay, you basically invert the second one and add them. Or basically you add the reciprocal of the second one, or add the opposite of the second one. And still use the same technique we used before, which was the tail to tip or the parallelogram method. I'll show you an example. So here's an example, two vectors, A and B, and I'm subtracting B from A. So with vectors, all I do, vector A minus B is the same thing as vector A plus negative B. Okay? And then I just go about doing what I've always done with vectors. Okay, I draw them. There's A. There's negative B. And then my resultant goes from where I start to where I end. So this is the answer of vector A minus B. Okay? Here's the thing that's kind of interesting with the vectors. When you subtract, the magnitude shouldn't have changed. It should be exactly the same magnitude as if you added those two vectors, but the direction will be different. I think that's correct. I'm just thinking that through right now. I think that should hold true. Yeah, seems like that would make sense. I know. You people at home, we just talked about it in class, and I was totally wrong. Disregard what I just said. Okay, so try this one out. V2 minus V1. They showed you there that it's the same thing as v2 plus negative v1. So just draw a sketch graph of what you think it'll be. Okay? Seem reasonable? So another big skill that you need to be comfortable with vectors is what's called breaking a vector down into its components, or finding the components of a vector, the x and y. And we did a little bit of this on Monday, right? You have a vector, you look for how far it moves in the x and y direction. We talked about that before. Everybody comfortable with that? Questions on that? Let's practice it. Basically, it's just using sine, cosine, and tangent, or something thereof. And if you have a vector and an angle, what you want to find is how large is that vector in the x and y direction. Give me a number. So imagine this is our vector here, that we've traveled 6 meters at a direction of 30 degrees above the east axis, 30 degrees north of east, or just 30 degrees for here. Please find how far you moved in an easterly direction and how far you moved in a northerly direction. Okay, or your east and north components, or your x and y components of that vector. Okay, so we just used sine and cosine, pretty straightforward. Any problems? If you forget how to do this, the cool thing is it's in your data booklet. It's in your data booklet. And here's what it looks like. Okay. So this is, it's in your data booklet, subtopic 1.3. It basically has a vector A and an angle theta. And it says, hey, the horizontal component of that vector is A cos theta. And the vertical component is A sine theta. Okay. If you're at home and you want to try this, try that one. Good. Okay. So we've talked about adding vectors when they're perpendicular to each other, and that's pretty straightforward because then we can just use right angle trig to solve for things, right? But when they're not perpendicular, it gets a little bit trickier, and this is where components can help us. This is where components can help us. And essentially, if I have vectors that are not perpendicular to each other, so here's vector A and here's vector B, and I'm adding them, what I can do is I can take them and break them down into x and y components. B sub x, B sub y, and A doesn't have any y. Vector A is all x, A sub y is 0, right? And now I can just add up the x's and add up the y's, and I'll have two vectors that are then mutually perpendicular, and I use trigonometry and Pythagoras to solve. Okay? So this is how one of the ways we deal with vectors that are not perpendicular to each other. Break them into their components, add all the x components up algebraically, super easy. Add all the y components up algebraically, super easy. And then you'll have a x and y to solve for. So essentially that's one of the things you can do with vector components is basically, you know, if you have multiple vectors, find their x components, find their y components, add them all up algebraically, that gives you the x and y of the resultant, and then use Pythagoras and trigonometry to solve. Here's a picture of it. This is kind of what it looks like. So here's V1 plus V2. They're not perpendicular to one another. I can draw it, no problem, and I get this resultant. That looks pretty good. If I wanted to actually solve for it, what I would be doing then is I would find the x component of my first one and the y component of my first one. Find the x component of my second one and its y component. Now, this is so abstract. Let's pick some numbers. Let's call this is 8, and this is 2, and I'll make that one 4, and that one 7. Okay? So now I add my x's. 8 and 4, what do I get? 12. Easy. So that's 12. And my y's? 9. Great. So that's 9. Now I have two vectors that are perpendicular to each other. One's 9, one's 12. I use Pythagoras to find the magnitude of my resultant. I use trigonometry to find my direction. Okay? So the cool thing about the simulation that I was hoping you were able to see a little bit yesterday is it draws the components for you, right? So the red thing, there's my vector. The pinkish purple lines, those are my x and y components. And notice that when I move this around, those components change. Yeah? And they give us values up here of what they are. So now the green line's my resultant. Notice this y component of my resultant is just that plus that, the two y components of my other vectors. And the x component of my resultant is just the sum of my x components of the other two vectors. And I can do this for as many vectors as I want. Well, then let's just, you can practice this. X and Y components, 6 at 42 degrees. Real quick, throw in your calculators. Tell me how the magnitude of the X component and the magnitude of the Y component for this vector. And if you're watching at home, hit pause. Try this out. Here we go. I'm going to show you the answers. Did you hit pause? I don't think you did. Better do it. Okay, good. There's the answers. 4.5 and 4 for X and Y. Pretty good? Feeling comfortable? This is such an important skill. I want you to do it again. Try that one. Try that one. Be careful with this one. I don't want you just to just punch in your calculator and throw out numbers. I want to know specifically which one's the X and which one's the Y. Which one's the X and which one's the Y. And you might have to think this one a little bit more than just being mindless. So, and technically also your X component should have been negative. -2, because it was going in the negative direction to the left. Okay? No problems? All right. You guys want to say farewell?
I believe that you can actually do physics. Just keep trying and maybe you'll eventually get it.
There you go. All right. See you later.